Okay, so we'll start. I'm not going to talk about this. This was something last year, so I'm talking something totally different. So about this one. So I think we have heard today lots about APIs, and we have heard about hop on RPC, about REST, and now we are going to hear something about in between. So Kekkonen, library we have been building. But first, I'll cover something about the API. So what's the scene in there, and then challenges with the technologies and offerings, and then about this Kekkonen we have been doing. So that's the story. And my name is Tommi Reiman, and I'm working for Metocin, and have been doing Clojure for like 4 years now. So about the APIs. Here are the different layers of APIs we have. First, we have the ClojureScript APIs, Clojure or ClojureScript, so just like the language itself. But that's not enough, so there's layers on top of that, how to make them usable in modern environments where there's usually a browser or some third party. So, but let's start with the basics. So, how do we do APIs with Clojure? So we have namespaces and we have functions, basically, and some methods to extend them, which are the multi-methods and protocols. And this is the thing we love. So there's an example API. So we have a method. We are using prismatic schema to get the types. So we have a function. We have some metadata. We have a description of that. And then we describe a parameter. So the function is dependent on the database and an ID, which is an integer. And what it does, it just calls a lower level database layer and does something. But that's not we cannot use that from the browser. So the first and simplest way would be to use some kind of RPC. And this is something, it seems to be that people are reinventing all the projects. I know we have done it a few times, and when I talked with other guys, they said that they have this really simple RPC. If they are using, they are owning the front end, they're using ClojureScript in the front end, and they are just serving that from their back end. So here's an example we heard about in the Hoplon presentation. This is the Castra. So just use macros or some other mechanism to tag the functions and create this pipeline that these functions are exposed outside of your JVM to the front end. So this is really simple. But what about the external clients? You have just some contract between yourself. So if you want to have a public API like SwaggerDocs, the current libraries are not doing that. And refactoring, if you have Clojure namespaces and you are exposing them outwards, if you change the namespace name, what happens? Web APIs. This is the thing we have been doing a lot. And Malcolm had some things about this to say. So, but this is a Composer API, route for the beer. So we manually map our Clojure functions to the HTTP terms. So you have a get beer function, which we did earlier, and you have to wrap it into this route, which is the get beer, and you think in the HTTP terms, so path parameters, headers, response codes, and stuff like that. But good thing is that it's easy to do. It's just an extra layer, and you get the SwaggerDocs, for example, in the Composer API sense. Then the REST APIs, you're mapping stuff into resources, resource containers, and that is a Liberator example. So Yada and Liberator are the two known REST libraries. But you think in terms of resources, so you map stuff into those. So that's what we have today. The future. David Nolan had an excellent presentation in Euroclojure about this stuff. I will just briefly introduce. So these data flows, bit same idea that seems to be in Hoplon already, but the Netflix Falcor and Facebook Relay, how do you like forget the server? So you just like expose your data in some query language, and in the client side you can make decisions how deep you are going to get that and how you get it. And there's an excellent blog about this, the web after tomorrow. And here's the like basic layering. So you have somewhere in the server you have all the data, and on top of that there is this security, so that it's your private data. If you just query against that, you cannot see anyone else's data. And on top of that, there's like these server layers and the browser. So you just like pull the data, and it just comes there. And there's another way to update that. But every library seems to be at the moment like bubbling up. So they are tech previews at the moment. But read the blog post. That's good. So, but what we are doing, so what is our problem? So we are building complex UIs, and we are using ClojureScript on the front end and using Reagent as the main tool. And like the customers also want like public APIs, so they have seen the Swagger, so they want that this is cool, we want to have that, so we cannot just use the own RPC. So that we want the both basically. And the like big thing is that because the problem domains are so that the same application is used by different kind of parties. There are like roles and business rules, and everybody is using the same application. And we have to enforce the rules on the server side, but we also have to enforce them on the client side. And it seems to be that we are duplicating the code. So is this button viewable is depending on so many things, and we have to like code. It's like old JSP times, so that this is the button and these are the rules how to show it, and then you send it to server, and server just revalidates that. So if someone still calls the API, we cannot do that. And the rest doesn't even try to solve these issues. So it's about like how you do the server side, and we want to have something on the client side too. So CQRS, briefly, so command and queries. It's just like a architecture pattern how you model your interactions. So it's verbs. So verbs instead of nouns. For example, like I have actually example in the next slide, but like what the client wants to do, it's a command. So it's like a reset password, it's a command. It's not on like an update on the customer which has a parameter of like password. It's just like reset password, and the like reads are queries. And it's really good for user interactions, because usually all the like rules seems to apply for these interactions. So who can like, for example, do this kind of operation? For example, like passivate some entity. So the passivate entity has a rule that it has to be active and it has to be in a certain state, and the like activate again has to be the same method but reverse. So it has to be passivated in some other like variable. So, but like if there would be like a GitHub API, we would probably do something like this. So we'd have like queries, list repositories, get a repository for one of those. Then there's like three buttons. It's watch. But at the moment, you cannot do that because you have watched it already. There is unwatch, which is doable because like you are watching it already. You haven't started the repo, so you can have a command give star. You cannot do remove star, and you can always fork the repo. So this is a thing we are like. This is a simple example, but in big applications, there are a huge amount of these invariants. So how we have to do that? And then there's these are the rules basically. So these have preconditions. So repository reads an ID and some like authorization check. Watch has a like constraint that it cannot be watched. The unwatch is the same but opposite. Give star, same thing, and fork can be done if you just have the rights. So what we did was, I think it was 4 years ago, there was the Lupapiste project, and me and Jarppe and Juha from Solita, we were architecting that, and there was our first CQRS library. It was like just for that project, but we realized that this is really good for that, because it's like building permits and the rules and regulations. There's so many of those, and everybody is using the same UI. So, and just like make it so that in the UI side you can just ask. So, do I have permission to run this like submit the whole application. And the rules are read from the server and like executed in the client side. So we don't have to duplicate the logic. Just say that these are the like commands or queries we want to execute, and we can ask from the server, can I do it? If I would do it, is it okay? And from that, we have for the last few years thought that, okay, we'll just write a library because we use the same modifications of the same library like in so many projects, and every one of those were successful on that side. So Kekkonen. Actually, I was just checking the dates. So we started to do this in 2012, the initial commit. There was something, but it was forgotten. And I started to redo that 16 days ago. So everything I'm showing today, it's done in the last 16 days, besides working. So I think it's a good proof of Clojure's power. So you can do really, you can build an API builder in like 16 days while doing something else too. So this is the thing we came up with. So APIs. We love the Clojure functions. We want to expose them, tag them somehow. And they are consuming messages. They are like message consumers. We have to somehow like categorize them. So we have to have namespaces. We don't want to use Clojure namespaces. We need virtual namespaces. We have done macro libraries, and that might not be the perfect way to do it. So data-driven, no magic, no macros. And like make it extendable so that people don't have to reinvent the same thing again. And like then the transport. So the web is what we are using, but abstract it away so you could have like a queue of some kind which are consumed by these message consumers. And the last thing, the client needs to be in like it's what we are doing, and the APIs are for the client, so it's in the like center of that. So the pieces, the ecosystem in Clojure is excellent. We have a huge amount of good libraries. These are the building blocks: schema, plumbing, a funhouse, ring swagger, from Composer API, the best parts, only the best parts. And schema tools, we have lots of stuff for that, so it's our library also. So that's the basic things. And what do we have? We have like those handlers, context registry, ring adapter, and API. But let's see how it happens. So the handlers are Clojure functions. They might have metadata. We collect them into virtual namespaces, which is basically a map keys. We collect them into this registry. And it has options. You can parameterize how you want it. And you can like create these contexts with some maps, basically, and just send it to registry and say that this is the target where I would like to send this. And registry routes that into the right handler. On top of that, because we are doing for the web, we need some kind of API. So the highest abstraction here is API. What the API does is like it wraps the Swagger UI. We have a ring handler. It could be turned into async handler. I think we are doing that because of yesterday's excellent sauna conversation. So we need async, but it's only one part of that. It's the only thing we have to modify. And on top of that, you can build whatever API you want. So let's see how our resolution goes. So this is like simple examples. So about the handlers. So we can make handlers which are like anonymous. There's a handler which has a name called Hello World. It's just a function. We can call it, and we get Hello World. We can add metadata there. We can like read the context. It seems to be lots of the same stuff in Java. We can do that. We can use the plumbing stuff. So plumbing is awesome because we have the schema integrated. So we just say that the data needs to be in that format, and we get like validation for free. And then like if we want to do with defunct, this is the highest form in plumbing. So describe the responses and like have this smart destruction. Who has been using plumbing? Yes, other guys, you should try that. So here we say that from data we extract that, and like that's the result. We can add a state there. So that now that everybody is just consuming one map, and like into the map you can put your components, your system, your global state. Here I have like a counter, and when I increment that, actually we don't have the. Let's go deeper. So this is how we create the registry. So we create and we give the options map. And in the options map, we have handlers which say that this is our application. We have API. Under that, there are subnamespaces. There are vars. You can collect vars. You can collect functions. You can collect symbols which do namespace scanning, which smells like spring. But you can do that. So you can say that from this namespace, all the stuff you can find consuming. It's in. You might be finding it useful. But let's create this registry. And now we have this context. It's the global state is there. We can ask there, is there a nil handler? No. Is there some this incremental handler? Yes. We got something. It's the metadata of that. We can invoke that one. And now we have the state. State is in the registry, and we just call through that, and the state gets modified. So you don't have to pass any parameters. They are in there. And and you can overwrite anything while you're calling. So this multi-tenant SaaS thingy we heard about. So you call them, and if you have a different system, different database, you just when you invoke that, you just put those dependencies into that context, and you get those. So whenever we say that, always use the atom 100. So it always has 101. So that's basics. How to extend that? So all the three pieces, registry, ring, and API have options. And here's, for example, the CQRS API. How did we build that? It's just one method. We use the API, and we pass in the options. So here we have said that only allow these type of handlers to come in. If you put something else, it says that there's some invalid stuff coming in. If for the ring mappings, these queries are gets, mapped to get, and the request query parameters are put to data, so we don't have to worry about is it header param, query param, or body param. And the commands, they read from the body params and map that to data. So everything is data. We can declare how it works. And another thing, how we can extend that is the handlers. So if we want to make this rule that this handler is only for the admin users, so we can use this extra metadata. And we have to register a handler for that. There's no multi-methods. There's no magic that if you import some namespace, something happens. You have to give these when you are building the API. So you know exactly what is happening. And you have, in the same namespace, different API implementation with different constraints. So easy to extend. And if you really want to do HTTP, this is not a REST library or HTTP library, but that would be the way to do HTTP-like thingies. So just say that we have HTTP API and allow these tags and map them to methods. And then you have simple HTTP. So let's see how it really works. So we have the GitHub API here. So here's for example, a schema of repository. There's one repository instance. There are commands, so this is how they look like. They are functions, you can call them directly if you know how to pass them. It is depending, it's just says that the response is a list of repositories. This was apidocs. And from the context, no parameters, but we want a repos component. So basic functions, same here. So we read the repos, we read the data. It's very this is basically from Funhouse. Funhouse has this syntax, and I borrowed that basically. I tried to build the whole library on top of Funhouse, but it was so tied to the HTTP spec, so I realized that it's easier to just reinvent that. But thanks, Prismatic guys. Done a great job. So that's a fork. Fork's a repo. We just need the ID and so on. But how does and then there's one constraint, so for bosses only. Where's here's our API. So what we are using is the let's hide that. CQRS API, we give the Swagger information there. We collect all the stuff we are wanting here. There's a default global state with the repos and counter. There's some user metadata handlers, and then there's transformers. So you can transform in any layer, basically. So you can do I will show you later. But yes, let's start that. I think that would be fun. So let's start the Jetty. It should be running now. Localhost, what do we get? Swagger docs, cool. So the default, you can set where you want it, but this is the thing. So from this namespace definitions came this kind of like application, and just all the parameters we have described are like usable here. So it gives the result. There was this one security thing, get user. It says no, where's our hidden boss move? I think it was here. Boss move, yes. So we try to call the boss move, it says missing role. We can say that we do the boss move for the guy number 1. Still missing role. So, but there's a guy with the API key. All done. So the guy 2, 3, 4 just managed to do that. And the security code is over here. So we have the like dummy API key authenticator, and we have like the how to enforce the rule. So that's the demo. I have still 7 minutes, hopefully. So this was what we started with. We have like a beautiful Clojure function, and we want to make it exposed. So what we do is just use plumbing, basically, and like wire it up. We have application, CQRS application, we just collect that. That's everything you have to do. Everything else is like set up. And we get the docs. So what about the client side? So Swagger docs are great for humans, and you could generate clients from that, but we haven't done that. We need Clojure data of all the APIs there are. So there are special endpoints which like are visible in here. There's always this Kekkonen namespace, and there's like at the moment 2 methods. All the handlers which are there, all the metadata which we know are like just like Clojure data. You can read it in JSON, or if you use transit, which is automatically with the middleware support that. So like you get the data into the front end. You get all the rules there. At the moment, the schema records are not going, but we have doing this for the schema tools. We do the full mapping for those. So you can all the data, all the schemas, everything is you can get it to the front end and make local decisions over there. So and 2 ways: either you do this speculative transaction. So before you are calling something, you can ask the Kekkonen API that, can I do this? Or you just like load all the descriptions and ensure that you have enough data to like make the local decisions. And I think the pull API and all the data mix stuff, that will fit really nicely here. So like get the rules from here and get the data from somewhere else. And this is like bad. This is not from our code base, but something like this has been done. So this is JSP horror. So you have reagent, beautiful HTML, and then you have some button, and it starts with this one rule, but then there are new rules, and suddenly all the logic is over there. So who can see this button? So we want to know it in advance. With this, we know that we are about to call the boss move with this button. We just validate, can we do the boss move? And the rules are coming from the server. So that's cool. So 16 days. 160 commits. It's not finalized. We know that this works because it has the old versions without the schema stuff have been used for like 4 years. And we know that we can do that, but we'll finalize it next few months. If someone has similar problems, you are doing like your own front end and your back end, and you want simple remoting and the rule management, just like talk in the bar, let's discuss. So we would like to hear your opinions. How to do that. And I think that Kekkonen, the like reagent template, that would be cool. So that if you want to set this small application up really fast, just like take all the good parts, and that's it. And the async, about yesterday's sauna discussion. So we have this one middleware, taken from Composer API. It's the only place which links us to Ring. So we probably talk to the async guys. So how to like do that. And the event sourcing later, so how to emit the events after the commands, but that's a separate thing. So that was all. Thank you for listening.